Okay, when we start taking notes on this investigation, it's really important that you take good notes.
Awesome.
I'm sorry, I just forgot what you told me to. 62. What's 62 say? Oh, what'd the word problem say? Can I have your book again, Ryan? All right. 62. You ready? It says the velocity, if this is a velocity function, oh, they really did do that. Okay, V is equal to K capital R squared minus little r squared. The velocity of the flow of blood at a distance r from the central axis of an artery of radius r. Okay, this is constant. The radius of the artery is constant. This is variable. K is also variable. Where K is a constant of proportionality, find the average rate of blood flow along the radius of an artery. Now, there's a word average rate, isn't it? Isn't velocity our rate function, rate of flow? Okay. So I think we need to talk, and did they tell us what the, all right. Let's talk about, now this is like off task. Let's say our velocity was feet per second, all right? With me? Okay. When we do average value, we're going to have 1 over b minus a times the integral from a to b of my function, b of t, correct? Times dt. All right, hold on, but this is off task for a moment. I want you to see how you play with units. At v of t is what units? Feet per second. Now, change in time is going to be what units? Time, seconds. So, ignoring this, if we were to integrate, our feet per second becomes what? Does it make sense? Feet should be position.
Yes.
Okay, so if we integrate, we're going to be at the position function, which is not a rate function. Are you with me?
Yes.
All right. This 1 over b minus a, what does the a and the b represent?
R.
Aren't those x's? And what does x represent? Time. So 1 over b minus a, oh, by the way, is 1 over seconds in units. So those seconds cancel, and when you multiply this, what do you come back to? Feet per second. So when you're given a, let's see what I want to call this. When you're given a rate function, and they ask you for average rate, then they're asking you for average value of that function, because your units, the time goes away, but now it's reintroduced. Are you with me? And think about this. Isn't slope y1 take away y2 over x1 take away x2? Yes? When you integrate this, aren't you getting into the big function when you integrate? And then when you substitute, won't that be f of b take away f of a, which is the difference in the y's? And this is the difference in the x's. Do you see the slope? Do you see the algebra 1 slope from average value? So this is coming at it from another perspective. So to do this one, what they want is they want the average rate or the average value. So we're going to say this is one, they said, from 0 to r. So this is 1 over r minus 0 times the integral from 0 to r of k times r squared minus r squared dr. All right, so I think we were supposed to go further. Let's see what happens. So this is going to be 1 over r, agreed? So I'm going to take times, can I bring this constant out? 0 to r of r squared minus r squared dr. That's a constant. So this is going to be k over r times. Now, this is a number. It is not a variable. So if I'm integrating with respect to r, what will this be? R squared times what? R. minus, this is a variable. How do we integrate that one? R to the third times 1/3. Why did I not do that process on capital R? Because that's a variable, that is a constant. The radius of your artery does not change. We're going to assume there is no plaque or buildup or whatever that stuff's called. All right, so this is going to be, now what do? We are going to substitute capital R every time we see what? Little r. So that's going to be r squared times big R minus 1/3 big R cubed. Minus, and I shouldn't have put that there. Okay, I'm going to put that in parentheses, and from that I'm going to subtract capital R squared times 0 minus 1/3 0 cubed. Right, but when you're in trig, that won't happen. So you got k over r times, all right, this is going to be r cubed minus 1/3 r cubed. What is that? K over r, that's going to be 2/3, because this is 3 over 3, right? In denominator 3, r cubed. Now what's going to happen with that little r, this r and this r cubed? Right. So it's going to be 2k r squared over 3. That is it. Sorry about that. That was kind of a nasty problem. But that was a cool problem, too. It brought us into that unit piece. Yes. 59. 59 said the graph in the figure is shown. Evaluate. All right. So we've got a, let me get graph paper. Log, I want medium. All right. So we've got this graph going on. Let me see if I can draw it accurately. We have 1, 3, 1, 3, and then we go down to 2, 1, and then we go up, down, over. Tell me over. 1, 2, 3. Okay, this is a good test question. Or is this a test question from before? They want the integral from 1 to 7 of, by the way, this is f function, f of something, f of x dx. So you are not given a function to integrate. You're given a graph of f. How do we find this? What are they asking for? What are they asking for? Yes, area under the curve. So what is this area right here? 1/2 height is 1, base 1, 1 plus, that's 1 base and there's 3. All right, plus, I would say, let's look at, if I were going to do this, I would look at this piece right here. How about all the way across? What is that? Rectangle plus what? 1 times 5, and what are we missing? We're missing the triangle. So if I look at this triangle and get something small enough to highlight, that's going to be half what? Well, that didn't work. 1/2 base times height. So that's half of 4, which is 2, plus 5, plus 1, 5, 6, 7, 8. So there's your A. Now, determine the average value. So that means it's going to be 1 over 7 minus 1 times the integral from 1 to 7 of f of x dx. So do we already know what this is? So on the AP exam, if they did this, what would you have had to do first, though they wouldn't have told you? You would have had to, wait a minute, oh, you would have had to find that whole area, correct? So we're going to take 1/6 of 8, or get 8/6, or get 4/3. That's part B. Determine the answers to part A and B if the graph is translated 2 units up. So if I move this up, if I move this up 1, 2, and this up 1, and this up 2, and this up 2, and this up 2, do you agree that what I have here is what we had before? What was added, basically? This stuff below, correct? So how much has been added? the integral from 1 to 7. Now this is f of x plus 2. Is that how we translate 2 units up? So that's going to be the integral from 1 to 7 of f of x dx plus the integral from 1 to 7 of 2 dx. What did you all tell me this was? This is 8 from what we got before, and you're telling me that this is 12. How do you integrate 2? 2x evaluated from 1 to 7. Graphically, you got 12. Algebraically, we better get 12 or that calculus doesn't work. So this is going to be 8 plus 2 times 7 minus 2 times 1. What's 14 take away 2? 12. See? Isn't that beautiful? So we now know that, what are we asking for? A. On part C, our new A is 20, and now our new B is going to be 1 over 7 minus 1 times the integral from 1 to 7 of f of x plus 2 dx. So that's going to be 1/6 of 20, which is what? 10/3. All right, D said, no, that's it. Okay, Eugene. Number 49. 49. Ooh, find the value C guaranteed by the mean value theorem. All right. So mean value theorem says, and what did they give us? Secant. Okay. Okay, so we're doing this from negative pi over 4 to pi over 4 of secant squared. Isn't there a 2? 2, I'm going to put that outside, secant squared x dx. And that's going to equal my f of c times pi over 4 minus a minus pi over 4. Do you see the mean value theorem? Okay. So this is going to be 2. What's the integral of secant squared? Tan x. And this is going to be evaluated from negative pi over 4 to pi. So what I did is I integrated the left. And this is going to be, isn't that pi over 2? 1/4 and 1/4 is 2/4. Okay, so this is going to be 2, and now we're going to do tan pi over 4 minus tan negative pi over 4 is equal to pi over 2 f of c. So I'm going to assume that you forgot how to evaluate trig because it's been a while. Okay, so I'm going to do it my way. If you don't like my way, then oh well, too bad. Figure out your own way. So this is going to be pi over 4, I know to be 45, which makes this a 45, 45, 90 triangle. So this is going to be tan is opposite over adjacent. So we know that that's going to be opposite over adjacent, which is 1. Now, tan of negative pi over 4 is down here. This is negative 1. That's positive 1. This is square root of 2. So now the opposite is negative 1 over 1. With me? F of c. All right, so what's this going to be? 1 plus 1 is 2. What's 2 times 2? So 4 is equal to pi over 2 f of c. How do we get f of c by itself? Multiply by 2 over pi, so I'm going to get 8 over pi. Right? Okay, so that's good. Now what do we have to do? So what was the original was 2 secant squared x is equal to 8 over pi. Now I'm going to put my c in for x. So 2 secant c, and that's quantity squared, equals to, what do you do first? Divide by 2. So we got secant c quantity squared is equal to 4 over pi. Now what do? That means secant c is going to equal a positive or negative, right? That's going to be 2 over square root of pi. All right, so I don't have a secant button on my calculator. What do we know 1 over secant is equal to? 1 over secant c is equal to cosine c, correct? Does that make sense? Okay. So if I want to use my cosine button, what do I have to do to this side? I have to flip it. So cosine c is going to equal plus or minus square root of pi over 2. You're going to need a calculator. So to solve this, you're going to do cosine inverse of square root of pi over 2. Did they give us an interval or not? From negative pi over 4 to pi over 2. Those are my x's. So what do we get? Make sure in radian. You gotta make sure you're in radian. I don't see you doing it. Are you doing it, or were you playing with your calculator?
No, I got 0.632.
0.63. Okay, will you do the negative one?
Yeah.
So are we gonna have a problem that requires graphing calculator on our test? Or?
I don't know. I'll have to look. Maybe, because we might have some applications. Is it positive? Okay, there you go. That's what C is. All right, I have to move on because I have to talk about this investigation. And if Kenny, let's see. Will you pass this back up to Ryan? Thank you. How'd you know I was going to see? I should put you on the end. All right. So this is a really cool investigation.
Oh, yeah.
All right. First of all, I want you to be aware. Several things. Make sure you take good notes. I promise I'll put this online. I need a pen. All right. You've got this curve, right? And this is 0. This, I believe, is 1. This is 2. This is 3. And this is 4. Okay? And they're telling you that the integral from 0 to 1 of this function, dt, is 4/3. Okay? So what does that mean? That means that from here, from 0 over to that line, all of this area is equal to what? 4/3. Okay, so that means this area is 4/3. Now on here they said the graph has odd symmetry about this point. What does that mean? That means this area is equal to that area. So what you want to do is there's symmetry here. So if this area is 4/3, what's this area? Okay, what is this area? Ooh, negative 4/3. And what is this area? Why are those negative? Because they're below the x-axis. And why are those positive? All right. Now, notice that it has 0 less than or equal to t less than or equal to 4. This is a bolo. What's bolo? Be on the lookout. Okay? When you see this, that is a closed interval 0 to 4. That means we do not go past 0 and we do not go past 4. Understood? Okay, there should be no arrows on these graphs. All right. The fact that f of t is in this position makes this what kind of graph? This is f of t. What kind of graph is this, if this is in this side of the integral? What is it? Well, maybe, but that's not important. Okay, because it's on this side of the integral, what kind of graph is this? It is a derivative graph. You got to keep that in your heads. You are going to have to justify. Okay? When the first derivative is positive, what's the original doing? Increasing. When the first derivative is negative, decreasing. When the first derivative is increasing, the original is concave up. When the original is decreasing, the derivative is decreasing, the original is what? All right, you need to remember that. When you get to page justification 40, you need to remember that. Ryan. Because it is f of t, and f of t is on this side of the integral. So when you integrate, you're undoing a derivative. Remember, it's called an antiderivative. Okay, so what I'm going to do is I'm going to be a sweetheart, and I'm going to get set up your first table. Because I want to make sure that you do everything I ask you to do. All right? They are asking you, their capital F function is the function 0 to x of f of t dt. Okay? So what does that mean? That means that you've got x value 0, 1, 2, 3, and 4. So I want to see under here the integral from 0. Now, what I always do when I do these is I set up my integral. Why is 0 always on the bottom? Because our function, the 0 is where? Now, what changes? The top. These are your x's. These are going to be your capital F of x's. So that's going to be 0, this is going to be 1, this is going to be 2, this is going to be 3, and this is going to be 4. How do you evaluate 0 to 0? Now, how do they expect you to do 0 to 1 of f of t? What are you supposed to look at? The area under the curve. What's the area under the curve from 0 to 1? 4/3. What is this? 0 to 2. 8/3. What is this? 0 to 3. That negative cancels that negative. You're back to 4/3. And what about this next one? 0. So now part B, it says you sketch that graph. So that means you're going to grab your graph paper. I don't want log graph paper. You're going to grab your graph paper and you are going to graph this. So the first thing you're going to do is what? Plot your what? 0, 0. I'm going to let this be 4/3. I'm going to let this be 8/3. So I'm going to let this be 1, 2, 3, 4. So 1, 4/3, 2, 8/3, 3, 4/3, 4, 0. Now, when you go to connect your dots, what are you going to think about?
Derivative.
It is a derivative. How am I going to connect this dot to this dot? I'm going to look at this, and what does this tell me? It's above, meaning I should increase. And because it's increasing, I should be concave up. In other words, I'm going to go from here, increasing concave up. Then what am I going to do? I'm still increasing, but I'm going to concave down. And then what? Concave down, because we're decreasing. And okay, because this is under, it's decreasing. Because it's decreasing, it's concave down. So I should decrease concave down to this point, then what? Right. Okay? That takes you through most of it. Now, we're going to go to page 41. Now, what do I want to say? If you copy this and the grid doesn't show up, then do your graphs on graph paper. All right. Everything on this investigation up until page 41 has a table, and it has what else? A graph. Now, when you get to page 41, the only thing you have are what? Okay, page 41, A through E. I must see table with integrals, and then the graph. If you don't do that, I'm going to be really unhappy. So, when you go to do these, the first one, x is on the bottom. Are we going to leave it that way? That should be dt, that should be little f. No. What are we going to do? Take the opposite. 0 must be on the bottom, x must be on the top when we're graphing. Any questions for A? Okay. For B. Okay. Let me also make this statement. I must see the table with integrals and then your graph, but I'm going to also, I must see transformed graph, because it's the transformed graph you are going to use to do this. Does not apply to A. It starts to apply to B. Must see transformed graph. On B, we have 0 to x, so we're good there. But now we're going to do f of negative t. What does a negative inside to the x value do to the graph? How does it flip it? Flips over the, it's going to flip over the y-axis. Okay? So what does that mean? Remember that graph in the beginning? Remember the graph in the beginning? How do we flip the graph if it looked like this? How do we flip it? Oh, just kidding. How do we flip this over the, it used to look, darn. It used to look like this. How do we flip it over this axis? It's going to look like this, right? So this is what we're looking at. Are you with me? You with me? So this is going to be 4/3. This is going to be 4/3. Sorry, you're going to be late to lunch. This is negative 4/3. This is negative 4/3. Now, this is a funny thing. You have negative t is between 0 and 4, correct? Yes? If I want to get this to be positive t and I multiply everything by a negative, what happens to your inequality sign? It switches it. So you see, when you go to do your table's not going to be from 0 to 4. It's going to be what? Negative 4, negative 3, negative 2, negative 1, and 0. All right. Looking at D. What happens when, okay, I'm skipping to E. What happens when you have the absolute value of f of t dt?
It's always positive.
What does it do to the original graph? This was your original graph.
Negative is positive.
What does it do to all your y values?
Makes positive.
It makes them positive. So this is your new transformed graph. I think, no, I'm not done. Okay. Now, let's look at D. This is going to be 0 to x. We are not absolute valuing the y's. We are absolute valuing the t's, correct?
Yeah.
What does that mean? That means t is between 0 and 4, right?
Yeah.
That's the positive t. And the opposite of t is what? Between 0 and 4. That means you are going to do both of these. Okay? How did we take care of this one? We multiplied through by a negative, correct? So what does this table look like? Negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3, and 4. In other words, for this one, you not only have the original graph that looked like this, yes? But you also have the opposite of t graph, which looked like this. So you are using this entire transformed graph to do this. Now remember, when you do your integral here, it's 0 to negative 4. Can you look at a graph in this order?
No.
So that means you are going to have to make that flipped, and you are going to be figuring out what's the area from negative 4 to 0, and then you take the opposite. This is going to be 0 to negative 3. That's unacceptable, so that's going to be negative 3 to 0. So now we go from negative 3 to 0. We find that, and we take its what? Opposite. Any questions? All right, now you can go. Yes. Thank you, Kenny. Oh, I need your homework left. Sorry.